Hi, in this first video on alcohols, I'm going to go over the acidity of alcohols. So the more stable the conjugate base of an alcohol, the more acidic it is. Now there's a few factors that can determine the stability of that conjugate base. The first one is going to be resonance. So for an example here, I've got two alcohols, cyclohexanol and phenol. So the pKa of cyclohexanol is 18, whereas it is 10 for phenol. So that's a 10 to the 8th magnitude difference. So if I deprotonate both of these, so first off I've got my cyclohexanol here. There's no resonance. So there's no way for that negative charge on the oxygen to be spread around multiple atoms. However, with phenol, I do have resonance. So this gives me then lone pair there, a ketone now. I can draw more resonance structures. And then this lone pair I can move around. And then finally, we can return to the initial deprotonated. So it's the resonance that phenol has that makes it a more stable conjugate base, and thus a more acidic alcohol. Number 2 is going to be induction. So induction means you have a nearby electronegative atom. Now the effects of induction aren't as strong as that of resonance, but it still certainly makes a difference. If I'm ranking an acidity here from least acidic to most acidic, so least acidic would be this guy. So that's less acidic than one that has 2 chlorides, and that's less acidic than one that has 3 chlorides. Right, so all of these have 2 carbons on them, but as you add the number of chlorides, it becomes more acidic because you have more induction. And basically what's happening is those electronegative atoms are pulling some of that electron density away from the deprotonated alcohol. So there's not so much negative charge on that oxygen. Then lastly, number 3 is solvation. So water in solution can help stabilize ethoxide ions. Right, ethoxide being O- ions. However, large alkyl chains can interfere with solvation. So for example, I've got two alcohols here. And I'm going to draw them in the deprotonated form. So we've got ethanol, and then we have tert-butanol. Oh, right, deprotonated. So that way they're consistent between the two of them. So when you draw the electron clouds here, right, you got the more electron density over here near the oxygen. And then, of course, the carbons and the hydrogens have electron density as well. I'm still able to fit in, all of these are solvent molecules, so in this case, water. With tert-butanol, however, I still have my oxygen area, but then I have a lot of area taken up by those carbons and hydrogen chains, and that really only allows me to have 3 water molecules around here. So these chains prevent more water molecules from coming and stabilizing that deprotonated alcohol. The pKa is 16 versus 18. So not a huge difference, right? That's still a magnitude of 100 in the difference of acidity.